Hello, my name is Emory Hill, and I will be presenting my motion of a falling object lab. So the purpose of this experiment was to compare three models, a realistic one, and then a drag model and a no drag model of an object falling. Behind this, there's a lot of physics. We have Newton's laws of motion. The first law recognizes the way force changes velocity. And then Newton's second law, force equals mass times acceleration, which is kind of the basis behind all of the equations we use. We have the equations here, position update, first kinematic equation. Those are important to track our object. And then velocity and drag. Obviously, the drag is needed for drag force, and the average velocity formula to get instantaneous velocity for the coding. Now, I used two softwares, Tracker and GlowScript. Tracker was where I uploaded the video, and it generated the first graph. And then GlowScript was where I coded the other two, the computational ones. So for a quick preview of the main results, we have all three graphs overlaid onto one, and you can see all of their slopes are slightly different. And this will all be explained through physics in a minute. First, I want to recognize the system, surroundings, and initial conditions. The system is the tissue pack. The surroundings are the air, the ground, everything else that could have acted on it. And it started with an initial velocity of negative 1.727 meters per second and an initial position of 1.242 meters up in the air. So for the procedure, the tissue pack was dropped in the air and it was recorded and uploaded into Tracker, which takes data from the video and generates the first graph. And then initial velocity was calculated from that and put into GlowScript. And then I did some other calculations in GlowScript to generate the other two graphs with drag force and no drag force. And then I overlaid them all into a Google Sheets graph. Now the coding in GlowScript was relatively simple. I just had to edit the framework. I changed the total time, the initial position and velocity, delta t, so it aligns with Tracker, the value of b, and this is important to note that the drag force was only recognized in one model. They were exactly the same besides the drag force, so there was the force of drag in one. And then the position and velocity update formulas as well. Now we have all three models here, the Tracker model, which is the accurate one, the most accurate one, and then the no drag model, that's the least accurate. It has the steepest slope as well. And then we have the drag model, which is kind of in between the two. So for a quick overview of the main results now, we have all three again overlaid onto one, as you could see before. The computational models are very similar, but the no drag one has the steepest slope and ends the lowest. This is because there is no force of drag opposing the velocity, so it falls the quickest. So for our analysis and conclusion, we have some similarities and differences. The computational models had very similar slopes, as I mentioned, and all of them have curves. That is because there is acceleration acting in that. And then they all had the same starting conditions. Now for some differences, the slope of the Tracker one was very flat compared to the other two, and the final positions were all different because of their different accelerations. Now, the Tracker model, as I mentioned, is the most accurate because it is the realistic one. So for some final questions, terminal velocity could be represented in the drag and gravity model, computational model, over a longer time span because the forces of drag and gravity would eventually balance out, making net force zero. And with zero acceleration, you can reach terminal velocity. Now, if it was thrown downward, it would do the same thing. It would just take a little bit longer because it has a higher initial velocity. And then eventually it would reach constant terminal velocity. So there's always potential errors. Human error is always reduced as much as possible, but I have to manually input in Tracker the positions. And then air movement in the room, while this maybe made very tiny minimal differences, that is realistically an error that could have occurred. And then a longer video is always better because it gives me more data points to work with. So if I had a longer video, I could have probably made everything slightly more accurate too. Thank you for watching. and enjoy your day.